During 1803, there's a scientist named John Dalton that explores the idea of what composed the matter.
I can see little particles around this object. What is this called?
After discovering that there are particles throughout the objects, he utilized math calculations to know further about the specific aspect of the particles.
How are these particles can be part in two? Such a strong band.
Thereafter, he concluded that atoms are indestructible particles that cannot be created nor destroyed through chemical reaction, which led to the proposal of 20 elements from this atomic theory.
But there's more. That's only a glimpse of what are we going to present today. So before we formally start, let us have a quick icebreaker. So the title of our game is called Who's This Diva? So several pictures of scientists will be flashed on the screen and you'll need to guess who is that scientist. So without further ado, let's start. The first one is Who's This Diva? Brent.
Albert Einstein.
Is it correct? Let's see. Wrong. So for our next we have Who's This Diva? Colleen. Isaac Newton. Wow. Is it correct? Yes. Yes, she is. For the last one, I know you know this guy. Yes. John Dalton. Where? Yes. Wrong. Oh, that's right. Wow. That's very nice. You're right. So after knowing various scientists and the teacher, let's take a look at John Dalton. Dalton, who are you? Wow. John Dalton is a scientist and the proponent of atomic theory. On 1803, he explored the idea of what is the concept of matter. So, after several years, he stated that all matter is composed of atoms and that atom is used to be indivisible and indestructible nor created by chemical reaction. An atom is the smallest particle in an element, which means one element is composed of atoms. So, through this discovery, it led to the proposal of 20 chemical elements. So, Dalton proposed 20 chemical elements throughout his journey. It takes about 5 years to him to discover the 20 chemical elements.
So how do we know if our elements are not the same or if it's completely new elements? Well, here it is. It is because the atoms of different elements differ because the number of protons, neutrons, and electrons they have. But the number of protons is the main factor. So, to summarize it, changing the numbers of protons means you have a completely new element.
And for another example, if I have the element hydrogen, which has one proton, and if I added another proton to it, I made a completely new element, which is helium. But adding a proton to an atom is not easy. It requires a nuclear reaction. But what is nuclear reaction? It is a process where two or more nucleus and a subatomic particles collide, resulting a change in the nucleus.
Atoms have different masses and chemical properties. Elemental differences, atoms of different elements, according to Dalton, have a different masses and distinct chemical properties, which explains the diversity of substances. For example, hydrogen and oxygen have a different atomic number and mass number. The hydrogen atomic number is 1 and the mass number is 1 in 784 10,000s, and the oxygen have a 8 atomic number and mass number is 15.999. Chemical reaction, John Dalton stated that compound are formed by atoms of different elements combined in fixed ratio, and that atoms are neither created or destroyed during chemical reaction, reflecting the law of conservation of mass.
Now that we've learned that atoms have different masses and properties, let's see how these differences explain how elements form various compounds. This brings us to Dalton's law of multiple proportions. This law states that when two elements combine together, it forms more than one compound. The mass of one element that combines with the fixed mass of the other will always be in small whole number ratios. An example is elements carbon and oxygen will form carbon monoxide and carbon dioxide. If we keep the amount of carbon the same, the amount of oxygen will double, and it shows 1:2 ratio. Dalton used these simple mass patterns as proof that atoms combine in fixed ways. Even if some of his guesses were wrong, his ideas helped scientists, especially modern scientists, understand that elements follow rules when forming compounds. This law supported his atomic theory and helped build the foundation of modern chemistry.
Because of these studies, future scientists after Dalton used this as a building block in order to benefit for their own studies. An example is Dmitri Mendeleev. He used Dalton's study, atomic weight, to organize the periodic table, which made it more predictive for us to know the elements and their properties. Medicine was also benefited, this time using Dalton's study on law of proportions. Since some rely on precise control in order to create specific molecules, long story short, even the slightest change in the elements could affect the drugs a person took. Since this study states that when two elements combine, it forms more than one compound, which made it easier for us to predict properties of elements.
To conclude this topic, John Dalton has a great significant impact on modern world of science. Through his atomic theory, it allows us to have a connection between various scientists that led to enhancement of matter and proposals of various chemical elements. Because of this theory, it helped us to innovate such as useful things that are significant for us nowadays. Like this, this, and this. And that concludes our topic for today's presentation. We hope that you learned a thing or two from us.